Hello and welcome to my write-up of Cold Start from TryHackMe. So Cold Start's an easy machine. It starts off with a white box source code review of a port 80 HTTP server. From there, you can discover a server-side request vulnerability to send requests on behalf of the server to reach an administrative backend only accessible from the localhost IP. From there, we can log on via SSH and exploit a wildcard injection to escalate to root. So let's just start off with a nmap scan. Nmap-scv. So nmap, we want to run it with the nmap scripting engine to run scripts such as whether we can find any vulnerabilities in the version, etc. Whether it'll run just some basic enumeration scripts on behalf of us, and then the v to enumerate versions, and then t5 to specify max thread count, which is the max speed that this tool can perform as, and then max verbosity to output lots of information when it's being run. I've already run this, and we'll just read it. You can see here we have port 21, 22, and 80, and port 21 allows anonymous login. So let's first check out FTP. Let's see if anything of interest is on. Anonymous. Let's see what we got here. Directory of pub. And what's inside? Backup file. Okay. Just get this file. And let's unzip it. Okay, it seems to be some sort of Flask application. So app.py is the standard naming convention of a Flask application. A Flask application is just a Python code that runs the backend of a server. It gives the ability to render HTML, CSS, and do web request functionality with Python, which is pretty cool. So let's just view this. And let's get the source code up. We'll just reopen it to avoid line wrapping and start from the top. So yeah, it's a Flask application. Just a page function and the app route. So app route is the function that'll be ran when this endpoint has been requested. So when someone requests the web root, it will run this following command, which is just going to return this HTML. So it's going to return this value body. So return page body. And what this seems to be is just a button that, or a form, sorry, that sends a GET request to the -preview endpoint on the web application. Let's view the -preview here. Preview, it takes in a request, so it's getting the request arguments and assigning it to the variable target, and if no arguments have been sent in the request, it will just return an error. And then it will go host equals, so just it's going to URL pass the arguments and then put it to lowercase. And then if the host is not in allowed host, so if the lowercase arguments applied to this endpoint is not in allowed host, it will return 403. Else it will send a GET request and then safely render the results. Okay, and you can see here down the bottom we have an admin route. Let's read what this does. So if the address requesting content from the server starts with 127 dot, continue. If not, abort. So if the request sent to the server of the -admin endpoint, if the IP sending that request does not start with 127, it will send a 403 request back. If it does, it will open some admin notes and return the value. What this is trying to do is essentially limit access to this resource or endpoint to the localhost user, which starts with 127.0.0.1. So let's just look at the web application to gain a better view. So let's just send a URL request to the localhost admin. Let's see if we can access the localhost admin endpoint. Host is not allowed in the approved internal allow list. Okay, let's see what is in the internal allow list. Let's see if host is not an allowed list. So allowed list is a variable defined in this source code. And it's up the top here. So allowed hosts, the only allowed hosts are kestrel.tryhackme. And it says here, this host name resolves to the local host via etc host. So on the machine, kestrel.tryhackme resolves to the local host, so its own web application running on its own host. Let's try this. Let's see if we can send a request to the admin endpoint via kestrel.tryhackme. So this will go through. Because this is part of the allowed hosts, and then a GET request will be sent on behalf of the server. And you can see here we now have results. So what this is doing is essentially the most basic form of server-side request forgery. So server-side request forgery is when you send a request on behalf of the server. So you get the server to send a request on behalf of you. So you may input something onto the web server, and then the web server itself will then send a request. And you can abuse this in all sorts of fashions, but in this case, we're abusing it to access content restricted to only the local host. And that's normally the type of thing you see in CTFs. But in like maybe a real world production environment, you may find things such as the backend is communicating with another API. You may be able to send requests to that API and then exploit an API vulnerability and get access to, say, an internal system, etc. But for the scope of this machine, this is quite simple and the most fundamental form is server-side request forgery. And let's access the admin notes index.php, I think. Admin endpoint, route p equals index, if p starts with nodes, okay. And you can see here we have access to some SSH credentials. Let's just copy these and connect via SSH. We have access. So with this machine, I just ran my common enumeration, just went through the steps of what I like this to do, and I discovered a cron job running in the daily cron jobs. We can view this by going into the etc cron.d and viewing the contents. You can see here we have a Vault Labs backup cron job. And let's just get the contents. And you can see here the shell has been bashed, the path seems like just a standard path, and this is the cron job. So it's going into the backups directory and then tarring all of the content of the backups directory into uploads tar gunzip. How can we exploit this? So you can see here it's using an asterisk. So this allows us to essentially utilize a wildcard injection. So how wildcard injection works is quite simple. It's quite similar to an SQL injection. The wildcard is resolved before the command is ran. So for example, we were to run the tar command. Let's just use this as an example. We run this tar cfz, sorry, to the ampersand. So what this would do is essentially tar all of the matches to this wildcard, which is essentially everything. So it will tar everything in the directory. This wildcard is resolved before the command is run. So before this tar command is actually ran, it will fill in the command with all the valid entries. So if you let's just show an example on my machine. So let's create a new directory, make directory tests and cd test, and we will contain let's just touch hello touch world. And what would happen if we run this command? Let's just run this command on our end. So what it would do is back up hello and world. But before the commands run, it will do the following. Or without the... you can see it's not backing it up because var backups doesn't exist. But what it's doing is resolving the ampersand to hello world. And what we can do is input parameters into that so it's interpreted in the actual command. So we could create a file called, I don't know, execute. And this would actually be interpreted in the command when the wildcard is resolved. This is essentially the same as an SQL injection, where an SQL injection arises where your user input is interpreted directly into the command, and it's not like parameterized. So we can abuse this. Dash execute doesn't actually exist, but there exists a way in where you can write parameters to execute commands, and I will show this here. So if we do the man of tar, and we go down a bit, you can see informative output. So the dash checkpoint and dash checkpoint action are what we want. So you can see the dash checkpoint action parameter runs an action on each checkpoint. So this will run a command when the checkpoint is reached. It'll run whatever we want when the checkpoint is reached. And the checkpoint allows us to change when the checkpoint is called. So when this, when you supply this dash checkpoint, what it will do is run the checkpoint action when it's reached, and it defaults to 10. And what this means is every time it does 10 iterations, or it like encrypts 10 files, it will run this checkpoint. And we can specify whether we want it to iterate through 3 files and then run the checkpoint action, or 1 file then run the checkpoint action. So we can create a file called dash checkpoint equals 1, and then we can create another file called dash checkpoint action equals, say, making the bin bash executable set UID. So that means that every 1 iteration of a file, it will execute our checkpoint action. So let's put that into testing on this machine. Let's just view that again, the Vault Labs, and it's going to the opt backups directory. So let's just go here to write a file, our files, and you can see here I've already placed the files in when I was doing this machine for the first time, and this is exactly what I've done. So I've created the dash checkpoint 1 and dash checkpoint equals exec sh shell.sh, and shell.sh just contains setting the bin bash to set UID. Another thing I want to highlight is actually creating a file called dash checkpoint action. So let's just try and create this file. We'll just touch it and put it in quotations. What's going to happen is it's going to interpret this as a parameter for its own command. However, you can stop this from happening with the dash. So touch dash. This tells the command line that that's the end of the parameters. So after this line, no more parameters are to be interpreted. And from there, we can actually supply this. So we're saying touch, and the end of parameters for touch, and then supplying the name. And you can see it's successful. And what we're gonna have to do is wait for the cron job to run. So let's just view this cron job again. And we're just going to wait for it to go in the backups directory and then upload or zip all of the files in the opt backups directory to var backups upload.tgz. And since the wildcard's there, it will directly put the checkpoint 1 and checkpoint action into the tar command, and therefore actually run the command because it's resolving into the command. And let's see if our command has gone through. So let's just look at the permissions of the bin bash file to see if it's been ran. And you can see here it has the permissions set UID. The sticky bit has been set, and the permissions every time you run bin bash are going to be ran with root. And let's do bin bash. One thing that's going to happen here is essentially nothing's going to happen. So we're going to run bin bash, and who are we? Web dev. We didn't escalate anything. This is because by default, bin bash ignores set UID and group UID. But if you just supply the -p, it will essentially preserve. So bin bash -p preserve the permissions on the file. So you'll see here, we are now root. And then we can read the root flag. And it's right here. And we have permissions. And that's it. I like this machine. It kind of highlights like a basic server-side request forgery and allows beginners to, gain a concept of the idea. I always like machines with like a white box code review because I think it's kind of cool. You get to see the inside, where doing a black box test you don't really get to see how other things work. It gets you used to how like a web application is set up. But thank you guys for watching.